Young people, welcome back. B in the house. Once again, guys, welcome in, welcome in. You know what we're doing. We're doing chapter 9. Chapter 9, lesson 2, solving quadratic equations by graphing. First objective, solve quadratic equations by graphing. Second objective, estimate solutions of quadratic equations by graphing. All right. So with that, students will be able to graph quadratic equations so that they can solve them. All right. You know what I do? I keeps it real. This one is exactly what we did in the last lesson, but it's for a different purpose. So the concept, you know, quadratic equations or quadratic functions. Quadratic equations, tomato, tomato, you know, but somebody will correct you. So we're still graphing them, but we're actually solving. So solving an equation. So the skill is solving, but we're going to solve it by graphing it. So is the skill graphing or is the skill solving? It's both. We're going to solve by graphing. So guys, I'm actually going to do a quickie. So it's going to be a good short video, guys, because this is one of the areas where I believe, as your bearded math brother, if you can graph it, you're good. If you want to dive deep, there's deep divers. Keep diving, man. Be the best you can be at anything, right? A motorcycle, fixing cars, cooking spaghetti, whatever you want to do, man. Be the best at it. So let's get this video started. All right, guys, so like I said, there you go. You see there's just 1, 2, 3, 4, 5, 6, 7, 8. And we're just graphing, right? So solving quadratic equations by graphing. You see 2 verbs in there, solving, graphing. So we're basically going to graph these so that we can solve them. In other words, there's a quadratic. It says x squared minus 2x plus 3 equals 0. What does x equal? Well, we can solve for x, do some stuff like factoring and quadratic formula. No, we're going to graph it. So let's go with what we know. Vertex, axis of symmetry, and of course, minimum, maximum is like we talked about last time. No. That's it. That's all I need. Vertex, x equals negative b divided by 2a. Go ahead and plug on in, right? We got our a, we got our b, we got our c. So plugging in negative 2. Thank you for the newcomer. And plugging in 1. So negative 2 is 2. Divided by 2 times 1, which is 2. So I got 2 divided by 2, which is 1. X is equal to 1. And this is what I know. People are going to stop right there. Oh, it's 1. No. The axis of symmetry is 1. So what we're saying is, right there, that's my reflection. What happens on the left is going to happen on the right. And hopefully, your teacher explains some of that. Watch the good video on it. Right. So the vertex is 1, comma. Well, here we go. What else do we have to do? Anybody remember? Here it is, guys. Not only do you need an x value, you need a y value, right? So if I have an x value, y is equal to x squared minus 2x plus 3. All we're doing is replacing the 0 at the end of that quadratic and making it y. So when x is 1, what is y? Y is 1 squared minus 2 times 1 plus 3. Y minus 2, y equals 1 minus 2 plus 3, which is negative 1 plus 3, which gives me 2. So my vertex is 1, 2. Let's go ahead and plot that. Boom. There it is. So here's where we understood now we can plug in more points to get more points, right? In other words, if I plug in 2 for x, what will y be? If I plug in negative 2, if I plug in 4, if I plug in positive 4, I have all these options. I can plug in any value to get more points because I'm graphing to solve. That's what we did last time. So guys, guess what I'm going to do? I'm going to plug in some points, some x values, because I have to graph this. And again, whether you call this a table method, you call it what you want, you're graphing. So when x is 2, what's y? Well, there we go. 4 minus 4 plus 3. You get 3. Let's do it again. What about if I plug in negative? And I'm thinking I better use a negative, because remember, you want to use 0, positive number, and a negative number when we're using a table. Well, this isn't a table. This is me seeing where the axis of symmetry is, so I win. All right, well, if 1 is the axis of symmetry, what about 2? The next whole number next to it, and then of course 0, right? So the unit right to the right and the unit right to the left. That's all I'm doing. Plugging in 0, plugging in 2. I'm choosing these values. And of course, nothing easier than 0, right? So there's my next value, and good, it is the same. That's that symmetry we're talking about, right? So here's your table to solidify, show a little work, whatever you want to call it, right? And plot those two, boom, and boom. And now guys, that's enough to make your U. It wouldn't be very accurate, but guess what? Boom, bang, pow, right? Graphed it, done. Well, I want to say I'm done. I want to feel like I'm done, but I gotta understand why I'm done. Where does that cross the x-axis? It does not. No solution. What does x equal? I don't know. It doesn't cross the x-axis. If it did cross the x-axis, I tell you, x is equal to 0, x is equal to 1. But that parabola, when we graphed it, it did not cross the x-axis. So guess what? No solution. That can happen. And hopefully your teacher explained that to you. And let's move on, because we got to do it again. Wow, I got rid of that beautiful number 1, just like that. Hopefully you took a picture. Rewind, you know what to do. All right, guys, so for number 2, again, A is equal to 1, B is equal to 6, and C is equal to 8. Let me go ahead and get my vertex formula, which is x is equal to negative b divided by 2a. Always write it, guys, always write it. It helps form permanency. That formula needs to be permanent as long as you're in this algebra class. Oh man, that's what I used to tell them. You need to learn it until June. I don't care what you do after that. So negative 6 divided by 2 gives me negative 3, so I got the first value of my vertex. Now y is equal to c squared, so parentheses squared, plus 6c, so 6 parentheses, plus 8, and again, plug in the value you got for x. So negative 3 and negative 3, y is equal to 9 plus negative 18. Always be careful on those integers, right? Plus 8. And here we go where y is now equal to 17 plus negative 18, and y is equal to 1. Got it. Again, guys, now that I have it, I'm going to graph that coordinate, understand my axis of symmetry, right? So there's my point. What are we going to do now? Oh, there it is, axis of symmetry. So y-intercept. Oh, where does it cross the y-axis? How do I get the y-intercept again? Oh yeah, plug 0 in for x and find out what y is. So c squared plus 6c plus 8 equals 0. Well, simple enough. That quadratic is going to be rewritten, replacing 0 with y. So y equals x squared plus 6x plus 8. All we did was change 0 to y and c to x. It's the same quadratic. Plug in 0 for x, 0 times 0, 6 times 0, guess what? Y equals 8. So now you know, right about here, right? Let's get it on there. Going up my y-axis, right there at 8. Now that axis of symmetry again is what I'm going to use to get another point. Count over. 1, 2, 3. 1, 2, 3. Now go ahead and get your U. And I'm doing it dotted again because it's be curved. But at the end of the day, guys, you're trying to get a solution. You're trying to find out the value. So where does it cross the x-axis? At 2 locations. crosses at -2 and at -4. And that's what you get. That's what you got. Now I'm plugging in because what does y equal? Well, when I plug in -2, guess what? Just guess. Just take a guess. Just take a guess. Yeah. That's what it's going to equal. Take a guess. Take a guess. 0. All right, guys. So again, 0 equals 0. That's called a check, right? But at the end of the day, we got 2 solutions because it crossed twice, right? When we were solving quadratics by factoring, right, we got 2 solutions, x equal 2, x equal -3. So we're used to this. Understanding what they're asking again, guys, we're solving. So that's why I checked x equal -2. Didn't check the first one though. All right, guys. The way that I started this one, remember I said it was going to be a shorter one because to me, this is the skill of graphing. And I'm still, showing you 2 solutions and, getting that all in. But we're graphing it to solve it. So solving a quadratic by factoring, by using the quadratic formula, or just by graphing. So this skill is solving a quadratic by graphing. So ultimately, if you can graph a quadratic using the vertex, axis of symmetry, or y-intercept. So again, going back to understanding what you understand. So do you know what a quadratic is? Yeah. You know what a graph is? Yeah. Do you recognize the axis of symmetry? Yeah. So then absolutely, then you understand it. As you can see here, guys, I'm still working it out, checking that the solution that I got is correct. It doesn't even say to check, it just says solve each equation by graphing. But this is that diving deep, right? And let's take another dive. 3 and 4. First thing I recognize is 3 only has 2 terms and it equals -1. We call that a red flag. So, when a guy pulls up, opens up the door, and all the water bottles fall out of his car, that's a red flag. So, what we want to do is make it equal 0. We can't do this unless our quadratic equals 0. So we added 1 to both sides because adding 1 to the right side gets rid of that -1, makes it 0. So now our quadratic reads x squared, a squared minus 2a plus 1. My a is equal to 1, my b is equal to -2, my c is equal to 1. So even though this quadratic has a as its variable, it still has an a, b, and c, right? Not confused at all. Using my vertex formula, x is equal to -b divided by 2a. I plug in -2 for b, plug in 1 for a, and -2 divided by +2 leaves me with -1. Wait. All right, y'all see what I see? That's when you have one of those mistakes that doesn't even mess it up. So my brain did something, but my mind knew better. Or my brain did something, but my heart knew better. So that's correct, guys. You see that -2 divided by 2 is -1, but it should be +2, right? So we broke that down. We got our x value plugged back in, got our y value, so we have our vertex. Basically, 2 plugins. Plug in, multiply, add. Plug in again, multiply, add, and you're done. So here we go. Oh, we're going all the way through. Y-intercept, plug in 0 for x, or in this case, a, right? So a squared minus 2a plus 1, plug in 0, and another 0, and of course 0 times 0, and -2 times 0, giving you 0. Oh, that was nice of me to say y equals, because we're getting the y-intercept. All right, so y is equal to 0, minus 0 plus 1, y is equal to whizzon. I said it like that, I know, whizzon. Oh, yeah, I can say whizzon. Keep you entertained. Because the music is good, but B&B is better. All right, so access to symmetry, there's my little dotted line, because remember what happens on the right side is going to happen on the left side. It's symmetric symmetry, access of symmetry. And this is where, again, I use the y-intercept, so now that point and that's all I need. I used to tell my kids 3 points. You make a U with 3 points. That's it. So got my 3 points. And here, I call this the KISS method. It comes up later on, we start doing quadratics. You notice how number 2 had 2 solutions? Well, this one has 1 solution because it just, boop, right there, hits that x-intercept, or x-axis, right, in 1 spot. It didn't go under it and come back up and hit it in 2 spots, it only hit it in 1 spot. So we got 1 solution this time, right? 1 solution. And we remember all of that from when we were solving and we had multiple solutions. So for number 4, again, they're trying to get you with having your quadratic not set equal to 0. So we set it equal to 0, and now we have n squared minus 7n plus 10. Bam. A is equal to 1, B is equal to -7, C is equal to 10. And thank you for taking care of that because, you know like I do, x is equal to, come on, let's get it, negative b divided by 2a. You should always write it, it helps you memorize it. Plug in the b, which is -7, plug in a, which is 1, so now it's a negative of -7, positive 7, divided by 2. Yes, fractions are in the world, or decimals, right? You're always dealing with whole numbers. So -7 divided by 2 is a -3.5. -3/5, okay? Don't laugh. Oops. Again, guys, BMB is human. And my editor is gonna love this. So, all right, guys, I wonder if we're gonna catch this one. -3/5, -3.5, and -3/5, are they the same thing? All right. So as we're watching this escape, BMB is rolling back and rolling back as these recognize. Hold on, something happened though. What happened is, I'm just gonna ride it out. Oh, I know what I'm doing. You know, every once in a while, I do a question, I do it absolutely wrong. So you can go into class and have the problem absolutely wrong. And your teacher be like, well, why is this absolutely wrong? And you gotta explain yourself. No, just kidding. All right, guys, it's working out perfectly. And we're gonna stop right here because, as I told you at the beginning, this is graphing quadratics. And how are we gonna graph it? We're gonna get the x-axis symmetry. Well, let me start. We're gonna get the vertex, the x-axis symmetry, and the y-intercept. And of course, we can always plug in and get a table of values. Guys, I hope you like this short one. Please comment, especially on this video, because I'm only gonna get better as long as you're here to help me out. See you in the next video.